Hi folks, this is Mundan Raghavan. Today we are going to see the Novice Machine Learning End-to-End project part 10 pipelines. In previous videos, we have covered look at the big picture, seeing the business requirement, get the data. In get the data topic, we have seen how to split the data and how to stratifying the data. And after that, we have covered the discover and visualize the data to get insights. In that, we have seen how to make the scatter plot and how to make the scatter plot with density and color map and how to see the correlation. Then after we were seeing the prepare the data for ML algorithms. In that we have seen data cleaning for missing values filling, and after that we have seen one-hot encoding. For example, it is for categorical variables. And after that we have seen the custom transformers to make our own transformer classes which are having fit, transform and fit and transform method. Then today we are going to see the pipelines. Let's general introduction about the pipelines. We have seen in previous videos that we have the different transformation over the data. For example, imputer class, and then we have created the campaign attributes adder. For example, it will be adding the new attributes to our data set. Like that, we may have for future scaling also. So for that reason, we understood that we will be having different transformation steps over to the data. But however, we are doing to the coding. But in sklearn, we have the special concept like pipelines. So what is it actually pipelines? Pipeline will be having a different list of transformers list. So as you see in the diagram, you will be creating the pipeline. In that pipeline, you will be listing out the transformers which has to be done over the data. Then after you will be creating the object for that pipeline with the data as the argument. So that means that whatever the data you are giving into the object, so that data will be taken into the list of transformers list and it will convert the transformation. And next one, we have the special one, column transformer. So in the above flow, we don't have any columns. So let's say you have the transformer list in the above flow. So it has to be for numerical categorical or it can be both. But however, our data should be based on the transformer list. For example, your transformer list having the transformers only for the numerical values, then your data argument should be only for the, it should be having only the columns for the numericals. Let's say your transformer list the having the transformers for only for categorical variables such as like one hot encoding, then your data argument should be having the columns for only the, let's say, text values or the categorical values. Again we have some issue here because we need to separate the data set with numerical with categorical as per the transformer list which we give in the first flow. But we have another one, column transformer. Here it the above, let's say above problem will be resolved here. For example, you will create the column transformer class. In that you will be having the list of pipelines or transformers with columns. So what does it mean? So here you will have the pipelines. Again, it will be the pipeline may have the list of transformer list inside that, or you will have directly only one transformer. So in any case, the data which has to be go through the different kinds of pipelines or transformer will be here with column names. So that's the specialty. So you will be mentioning the transformer or pipeline with column names. That's all. Then after you will be creating the column transformer object with the data as argument. So what happens here actually? So from the back we will come. So you will giving the data. So the data may have any number of columns with any kind of data, let's say numerical or categorical. Then it will go to the pipeline or transformer. But before going to that, it will be checking for the columns. In your data set, whichever the column matching with this transformer will be taken into that particular transformer or pipeline, it will be converting into the transformations. Then you will be getting the output, right? So let's see more details in the coding. As we discussed in sklearn.pipeline, from there we are going to just import the pipeline. And after that, we are going to import sklearn pre-processing import standard scaler to apply the future scaling. Here we can see the same image. So we will see the first one, pipeline, transformer list, and pipeline object with data as argument. So before going to that, we will see housing underscore num. And here we are going to have only the data, numerical data. So you can see directly here. So longitude, latitudes, and so on till median income. Fine. So it has only the numerical. Now I am going to create the pipeline object. So you can see the first flow, the pipeline, then after transformer list. So before giving the transformer list, I'm giving the name for that, just logical name. So imputer, I'm going to give the name, and simple imputer. This is one transformer. This imputer will be working on the strategy based on the median. Then after I am giving the another because another transformer, it can have a transformers list, right? So another one I will be giving the attributes adder. So this will be our customized transformer or our own transformer, combine attributes adder with the argument which has this. And then after standard scalar name, and I am giving the transformer as standard scalar. So what happens now? We have created the pipeline here. So we have not provided any data to that. Now you create the num underscore pipeline, which is our reference to the pipeline object. Then fit transform method, and I am passing the housing underscore num. So this numerical data will be sent to the first step. It will do the fit and transform for simple imputer transformer class. And after that, that output will be passed to the pipe to the next one. Then those information will be transformed, fit and transform by using the this transformer combine attributes adder. Then after that output will be piped to the second one. It will be the standard scalar. Then it will fit for the, let's say, the previous output. So for the same data, we have transformed for the different kinds of transformers like simple imputer, then followed by combine attributes adder, and followed by the standard scalar. Now we will be having the total outcome. And next one, from sklearn compose import column transformer. So this class will be available in the sklearn 20 version. So let's see. So as we discussed, we need to give the column names as well, right? When you give the list of pipelines or transformer. So for that reason, we are getting the list of column names. From the housing num, we will be getting the list of the column names for the numerical values. And we know that the list of categorical column names will be only one in our case, that is ocean proximity. Now we have both list. Now we are creating the full pipeline. So creating the object for the column transformer. Okay, fine. Then after, as we discussed, first we will be giving the logical name, numerical. Then I am giving the pipeline here. So this pipeline may have a number of transformers again. Let's say you can see here 3 transformers. So these transformers are ready, and numerical attributes. So the column names also available. Next one, categorical, and I am here giving only the transformer because I don't have any multiple transformers list for the categorical attributes. Now I have given the transformer here, and I have given the, let's say, the attributes or the column name for the categorical values. So now what happens? So now I am creating the object for the full pipeline, fit, transform, then I am passing the housing. So what is housing? The housing is the entire data which has everything, which means that it has the categorical data as well. So here we are not going to split anything, adding anything after some time. So directly we are giving the data. The only thing is we don't have the label here, or we don't have the dependent variable. So let's see what is the flow actually. So you have given the entire data. So from the data, it will go to the pipeline. So from the data, you may have, let's say, a number of columns. In the columns, whichever the column matching with numerical attributes, that will be taken into the numerical pipeline. So this pipeline will be having 3 transformers. So 3 transformers has be applied or will be applied to the data from this housing, which has the columns from the numerical attributes. What happens to the next one? So from the same housing dataset, we will be having the categorical attributes which matches this column name from the dataset. It will be sent to the transformer one hot encoder. So those information will be transformed. And at last, those all the columns will be concatenated, and it will be giving us the output. That output we are just saving into the housing underscore prepared. So just see the housing again. So we have seen the entire data set already. Now let's see the housing underscore prepared. We know that the output of, let's say, fit and transform method will be the numpy array. Just to see as a data frame, just I am converting pandas dot data frame and the numpy array. Now you can see totally 15 columns. So why it is 15 columns? Let's say in housing, totally we have 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally we have 9. here we have totally we have, let's say 15. So what is it that? So let's say the inputs 1 2 3 4 5 6 7 8 9. So our 9 inputs has been added here. Then after, sorry, 1 2 3 4 5 6 7 8. Okay, 8 values. Sorry. So 8 values has been added, and after that we have added 2 attributes by using the combination of, let's say here, combine attributes. So that's why we have added 2 more columns. Then after we have one ocean proximity text column. So that is the categorical. So the categorical has been converted into the one hot encoding. So we have 1 2 3 4 5. So 5 columns for the categorical, because we have seen 5 unique values in the ocean proximity. So that's why 5 binary variables has been created. Wherever you find the value, that value has been having the value 1. So this is all about this video, and we have seen what is pipeline, and we have seen what is a column transformer in this video. So we are almost nearing to the end, and we will be predicting the model. We will be selecting the model and predicting the predictions in the future videos. So thanks for watching.